So this video introduces us to geometric sequences. So the difference between geometric sequences and arithmetic sequences is when you analyze the pattern of numbers, in a geometric sequence, you are multiplying by something each time. In an arithmetic sequence, you are adding by something each time. So that is the key difference between a geometric sequence and an arithmetic sequence. So say you have the numbers 4, 2, 1, a half. You are still multiplying by something each time here. You're multiplying by a half. Okay, so in its most general form, if we remember, a of course is our first term. This time we're multiplying by something, so we're going to call it OR. In other words, the common ratio OR stands for, okay, because it is the same thing that we are multiplying by each time. So we're going to call it OR for the common ratio. So your first term is A, that means your next term would be A times OR. A OR. And of course, if you multiply by OR again, you're going to get A times OR squared. And if you multiply by OR again, you're going to get A times OR cubed. So what you have here is the first term is A, the second term is A OR to the power of 1, the third term is A OR to the power of 2, the fourth term is A OR to the power of 3, the fifth term will be A OR to the power of 4, the 10th term would be A OR to the power of 9, following that pattern. The 20th term would be A OR to the power of 19, which would lead to the nth term being A OR to the n minus 1. And that is what is in our log tables. We have an expression for the nth term of a geometric sequence is A times OR to the power of n minus 1. Okay? So let's try a few questions now, having a play around with this particular formula. Okay, so in this question, we are told it's a geometric sequence and that the third term is 32, the sixth term is 4. We're asked to find A and OR and the first three terms of the sequence. So this is what we have got at our disposal. This is our formula here from our log tables for the nth term. So pause the video, see how you get on with this if you'd like to have a go at it straight away. If you want to see an example being done, then we'll work through it there together. So just like I would have done with arithmetic sequences, you're going to get your bit of information and sub it in as best you can into what you have. So here I know that n is going to be 3 and that this should all work out to be 32. So for T3, you have A, of course, I don't know, or I don't know either, I'm looking for it. And then 3 take away 1, which is going to be A OR to the power of 2. And we know that T3 is, of course, 32. So we know that's got to equal 32. And that's as far as I can go with that. And then we have that T6 is equal to A we don't know, or we don't know. N is 6 minus 1. So we have A OR to the power of 5. And that sixth term is, of course, 4. So put that in, and that's as far as I can go there. So now what we've got to do is work with these two equations. So as is the case with all non-linear simultaneous equations, what I mean by that is anytime you have a power, we can't go down the elimination road, we have to go down the substitution road with our simultaneous equations. So what we're going to do is take the easier of the equations and get A equals or equals and sub it into the other equation. Now it's quite obviously going to be much easier to get A equals than it is to get OR equals, okay? With the OR being squared, you'd have to square root and everything to get the OR. So we'll go with getting the A equals and then sub that in here to the other one. So if I have 32 is equal to A OR squared, then to get A on its own, I'll divide both sides by OR squared. And that gives me 32 over OR squared. So what I'm going to do now is I'm going to take that and substitute it in for the A here. So instead of 4 equals a or to the power of 5, I'm going to get 4 equals 32 or squared times or to the power of 5. Okay, now what's going to nicely happen here is we have 32 or to the power of 5 divided by or squared. Your or squared will divide into or to the power of 5 and leave you with or cubed. So we're left with 4 is equal to 32 or cubed. And so now divide both sides by 32. We get or cubed is equal to 1 over 8. And then to get or on its own, we cubed root 1/8. And the answer is a half. So or is equal to a half. Take that now. I will go back up here. Since we know that a is equal to 32 times or squared, sub the value for or in now to this easier equation. So a is equal to 32 over a half squared, and we get a is equal to 128. So there's your value for a, and there's your value for or. Okay, so now we've got a and or. We've been asked for the first 3 terms of the sequence. So back to our nth term, of course. Term 1, well, we already know term 1 is obviously a, 1 to 8. Term 2 is going to be a, 1 to 8, times or, a half, and to the power of n minus 1, so it's the power of 2 minus 1, in other words, to the power of 1. So we get 1 to 8 times a half to the power of 1, which works out to be 64. So there's our second term. And the third term then is going to be 1 to 8, which of course is your a, or is a half, to the power of n is 3 minus 1, of course, filling that in. And that's going to be 1 to 8 times a half squared, which works out to be 32. So there's your first 3 terms of the sequence. Okay, so try this question. If the second term is 4 and the fifth term is minus 1 over 16, find a and or and the first 3 terms of this geometric sequence. Okay, so if you're feeling confident, pause the video and see how you get on with this one. Alright, so again, this is what we have to work with here. It's a geometric sequence, so this is your nth term formula. So we again are going to fill in our information as best we can. So for the second term, n is 2, a we don't know, or we don't know, and of course 2 minus 1, that gives us a times or to the power of 1, and of course the second term works out to be 4. So that's as far as we can go with that. Filling this information in, then we have the fifth term is equal to a times or 5 to the power of 5 minus 1, which is of course a or to the power of 4, and we know the fifth term works out to be minus 1 over 16. So that's as far as we can go with that. Alright, so again we're going to use the substitution method for these simultaneous equations. So I'm going to take my easier of the 2 equations, and I'm going to get a is equal to 4 divided by or. Okay, it's going to be much easier to get the a. In this case, I know there's no power on the or, but it's still always easier in all of these to get the a value for, or a term for the a, and sub the a into the other. So that's exactly what we're going to do now. Take this value for a and sub it in here. So I get minus 1 over 16, and instead of a times or to the power of 4, I'm subbing in 4 over or times or to the power of 4. Alright, so tidying that up then, I get minus 1 over 16 equals 4 times or to the 4 divided by or. So or to the 4 divided by or, that will divide into that and give you or cubed. So I'm left with minus 1 over 16 equals 4 or cubed. Okay, so now to find or, I divide both sides by 4. That will leave me with minus 1 over 16 divided by 4, which actually works out to be minus 1 over 64. And then to get or on its own, I'm going to cubed root that. and the cubed root of minus 1 over 64 is minus 1/4. So that's my common ratio. So I'm going to go back up here now and find out what my A is using this value of R. So 4 over R, in this case, R of course is minus 1/4, so sum it in, equals A. So A works out to be minus 16. All right, so there's my A and there's my R. And the next thing in the question I need to find are the first 3 terms of the sequence. So again, back to this. First term, well, the first term is always A, so I've got that already, minus 16. The second term is going to be A, which is minus 16, times R, which is minus 1/4, to the power of n minus 1, so to the power of 2 minus 1, which works out to be 4. And the third term is, of course, A, which is minus 16, R, which is minus 1/4, to the power of 3 minus 1, which works out to be minus 1. So there, your first 3 terms of the sequence. Okay, let's try this question. So here we have that the product of the first 3 terms of a geometric sequence is 216. Their sum is 21. Given that the common ratio is less than 1, find T1, T2 and T3. All right, pause the video and see how you get on with this one. So again, we are working with this geometric sequence, nth term formula. And I know that the product of the first 3 terms of a geometric sequence is 216. So let's work with that first. So let's get an expression for T1, T2 and T3, because I know the product, which means when you multiply them, multiplying each of the 3 terms will give me 216. So my first term obviously is A. My second term is A times R to the 2 minus 1, which of course is A R. And the third term is A times R to the power of 3 minus 1, which of course is A R squared. So we have A times AR times AR squared is equal to 216. The product, in other words, when you multiply these 3 terms, we're getting 216. And when you add the sum of these 3 terms, so A add AR squared is 21. Okay, so here's what we have to work with, and there are 2 quite complicated equations here. So let's just take our time, use the same method as we did before, and bit by bit try and get as far as we can with this. So let's first of all try tidy this up. All right, we have 2 equations, both nonlinear, so again we have to do our substitution method. So as before, I'm going to try and get A equals and sub it into the other one. Okay, so simplifying the left hand side here, A times A times A is A cubed, and R times R squared is R cubed. So A cubed times R cubed is 216. So if I was to try and get A on its own here, I divide both sides by R cubed, and I get A cubed is equal to 216 over R cubed. Okay. Now it would be lovely if I had an A cubed on this side that I could sub this straight into, but it doesn't look like I'm going to get that. If I'm trying to add these terms together, with algebra and addition, you can only add together things that are the same. So none of these terms are the same here, which means they can't be simplified. What might be just a little bit easier for me to do is pull out that A though, so I at least have the A on its own. So in order to get A back again, I'd multiply by 1. In order to get AR back again, I'll multiply by an R. And to get an AR squared back again, I'll multiply by a squared. This just makes it easier to have the A out here on its own. So again, I don't have an A cubed. I can't sub this in straight away. I'm going to have to evaluate this further. If I have A cubed equals 216 over R cubed, A then would be the cubed root of this. Now I will be able to tidy this up a little bit, because If it's the cubed root of this full fraction, that means I can cubed root the top and I can cubed root the bottom. Okay, and when you cubed root 216, you get 6. And when you cubed root r cubed, you're going to get r. So that's a little bit nicer to deal with. So a is equal to 6 over r. So I'm going to take that now and I'm going to sub it in here for the a. So I end up with 6 over r times 1 plus r squared is equal to 21. Okay? Now, rather than multiply in by this fraction, what I'm going to do is I'm going to get rid of this divide by r straight away. And because this 6 over r is being multiplied to this is like one whole term. So the minute I multiply by r on this left-hand side and multiply by r on the right-hand side, I will get rid of that denominator. And all I need to do is multiply by that r once. So that's what I'm going to do straight away, just to make things a little bit easier for myself. I'm going to multiply that by r and I'm going to multiply that side by r. And in doing that, I get rid of that nasty fraction that I don't want to have to deal with. And it's left me with the 6. And on the right hand side, I have 21r. So now I can multiply in by the 6. 6 times 1 is 6. 6 times r is 6r. And 6 times r squared is 6r squared is equal to 21r. And now I'm going to try and tidy this up as best I can. So I'm going to take away 21r from both sides. And I'm left with 6 minus 15r plus 6r squared is equal to 0. And look what I have here. Here I'm now left with this quadratic. Okay, so the first thing I'm going to do, if I just rewrite in this form, the way I would normally have a quadratic, straight away I can spot that I can divide everything by 3. And by dividing everything by 3, it means I'm going to simplify the quadratic. So 6r squared divided by 3 is 2r squared, minus 15r divided by 3 is minus 5r, and 6 divided by 3 is 2. 0 divided by 3, of course, is 0. So now that's going to be much easier to deal with. Again, you've always got two options with solving a quadratic. You can use the minus b formula or the factorizing method. So I'm going to factorize it. First number by last number is 2 times 2, which is 4. Factors of 4 that are going to make a minus 5r would be 4 times 1, and a minus and a minus would give me minus 4 and minus 1 added together make the middle term minus 5, and multiplying the two terms, minus 4 times minus 1 gives me a plus 4 here. So that's exactly what I want. So rewriting the quadratic, I get 2r squared minus 4r minus r plus 2 equals 0. And we can see that's totally equivalent to this. I've just rewritten the middle term as minus 4r minus r. Now looking at these two, pulling out the common term, 2r times r minus 2. And here, I can't pull anything out really, so I'm going to pull out 1. You know these brackets have got to be the same, so r minus 2 needs to go in there, and that would make that sign would need to be a minus. Let's check this works. Minus 1 times r is minus r, and minus 1 times minus 2 is, of course, minus by minus plus 2. So that does work. So now these two terms that are broken up go in the first bracket, and the repeated term is in the second bracket. So I end up with 2r minus 1 equals 0, or r minus 2 equals 0. And so add 1 to both sides, I get 2r is equal to 1, divide both sides by 2, and I get r is equal to a half. Add 2 to both sides here, or r is equal to 2. So if you remember back in the question, it did tell me that my r was less than 1, which means that's not applicable in this question, and that this is the common ratio I'm dealing with in this geometric sequence. Okay, so now I found the common ratio. I now want to go back and make sure I have the 3 terms they've asked me for, T1, T2 and T3. So T1, of course, is going to be A. So if we go back to here, I'm going to be able to find my A. A is equal to 6 divided by the common ratio, and we now know the common ratio is, of course, a half. So 6 divided by a half is 12. So that's your first term A. Term 2 is going to be A, which is 12, times the common ratio, which is a half, to the power of 2 minus 1, which works out to be 6. And the third term is going to be A, which is 12, times the common ratio, which is a half, to the power of 3 minus 1, which works out to be 3. So they're the first three terms of the geometric sequence. Okay, so try this question. 3x and x plus 6 are the first three terms of a geometric sequence of positive terms. Find x and then the first three terms of the sequence. So I don't know if you remember, we had a question similar to this when we dealt with arithmetic sequences, okay? And again, all we had to go on was the fact that because we know it's a geometric sequence, we know that you're multiplying by a common ratio each time, okay? So is that ringing a bell for you? See if that's enough of a hint. If you feel it is, pause the video and see how far you can go yourselves now on this question. If not, if you need to remind yourselves of exactly how we might approach this, then keep playing and we'll work through this one nice and slowly. So a little recap. If you have a geometric sequence, let's say you have 2, 6, 18, 54, all right? What we know is, we know it's going up by times 3 each time. The common ratio is 3. So in analysing this, we know that 6 divided by 2 will give you that common ratio, and 18 divided by 6 will give you that common ratio, okay? Now I know in this scenario we know that the common ratio is 3, but in this scenario we don't know what the common ratio is, but we do know that it's the same each time. What you are multiplying from one term to the next has got to be the same each time. So this is the concept we're going to use here to help us work out the value for x. In other words, since I'm not multiplying by the common ratio here, I know, just like I did here, that x divided by its previous term has got to be equal to x plus 6 divided by its previous term. And that will give me an equation to work with, okay? Because x divided by 3 will give me the common ratio, and x plus 6 divided by x will give me the common ratio, and they have to be equivalent because I know it's a geometric sequence. So now, working with this equation, as always, because I have an equation and I've got fractions, I don't want to have to deal with fractions, so immediately I'm going to get rid of them. If I have a divide by 3 and a divide by x and I want to get rid of them, I'm going to multiply both sides by 3 and x. And I can do that because it's an equation. And what I do to one side, I can do to the other and still keep it balanced. Okay? So I'm going to multiply that side by 3 and x. And I'm going to multiply that side by 3 and x because they are my two denominators. That will cancel with that then, and the x will cancel with that. So I'm left with x times x on the left hand side, which is x squared, and 3 times x plus 6. Be careful there. We've got 3 times x, which is 3x, and 3 times 6, which is 18. So now look what I have here. If I tidy this up, bring everything to the left hand side, I have a quadratic. So again, you have two options always, minus b formula or factorize to solve it. It's a nice easy quadratic, so I'm going to jump straight into factorizing. Factors of minus 18 that would add together to give me minus 3 x. So minus 18, the two factors that would work here would be 6 and 3. Obviously I'm going to have different signs, and if they have to add together to make a minus 3x, it'd have to be minus 6 and a plus 3. So what I end up here with is x plus 6 times x minus 6, x plus 3 times x minus 6 equals 0, which implies that either x plus 3 equals 0 or x minus 6 equals 0, which gives me x is equal to minus 3 or x is equal to 6. Since it said in the question that it was a geometric sequence of positive terms, I know then I can't have this minus 3, because that x on its own is the second term. That would imply that second term is minus 3. So I can't have that. It's got to be positive, so I can disregard that particular solution and know that I just need to take that one there. X is equal to 6. So there's the first answer. They asked me to find x. And now to find the first 3 terms. Well, the 3 terms were 3x and x plus 6, of course. So my first term is 3. X is the second term, which I've got as 6. And the third term is going to be 6 add 6. So my 3 terms are 3, 6, and of course 12. Okay. Last question, so try this one. If you have the terms 5, 15, 45, ... 3645 in a geometric sequence, find how many terms are in the sequence. Okay, so in other words, if that's the first term, that's the second, that's the third, which term is 3645? Okay, pause the video and see how you get on with this one. So again, what you have to work with here is this. So let's see how I can fill this in as best I can. Obviously, I don't know what n is. I just know that I want to find what term 3645 is in this sequence. So I'm looking for n, okay? But can I fill in a? Well, a I know straight off is the first term 5. Or the common ratio. Well, again, by inspection, I can see the common ratio is whatever is going up by each time. And straight off, I can see that we're timesing by 3. So the common ratio is 3. I don't know n, so to the power of n minus 1, but I know that for this particular term, 3645, when I figure out the value of n, I know this should all result in 3645. All right. So basically I need to solve for this. So here's where you've got to be careful, because we're solving for a power. So my first step in solving this is to try and simplify it a little bit. And the first thing I can do is get rid of this 5. This 5 is being multiplied to the 3 to the power. Now, I can't divide by 3 because the 3 has a power attached. So remember your BODMAS rules. Be very careful. That 3 is a power. I can't do anything to that. But the 5 is just being multiplied. So I can get rid of that, dividing both sides by 5. So that will cancel that out and leave me with 3 to the power of n minus 1 on the right hand side. And 3645 divided by 5 works out to be 729. Okay, now your only 2 methods for solving for a power from your junior cert way would be to get the left hand side looking like the right hand side. In other words, if you've got a power of 3 on the right hand side, you want to try and get 729 written as a power of 3. So if you do a little bit of trial and improvement on your calculator, see if you can get 729 written as a power of 3, you will figure out that 3 to the power of 6 is equivalent to 729. So if I write 729 as 3 to the power of 6, then you're writing it similar to the right hand side. So you've got 3 to a power is equal to 3 to a power. And once you've got the left hand side looking like the right hand side, you can then equate the powers. So 6 is equal to n minus 1, add 1 to both sides, and we have 7 is equal to n. Now that worked out quite nicely because n was a nice whole number. It may not always work out as nicely as that in other situations. For geometric sequences, naturally our sequence should be a positive whole number in this particular scenario. But if you had a situation where you're solving for a power and again you didn't know whether it was going to be a whole number or not, then your other option, of course, and this is the leaving cert higher level approach, which is to use logs. Okay, so when you're using logs, you're always filling in these 3 elements, and log is another word for power. So your log is always equal to your power. So in this case, in this particular scenario, the power is n minus 1, so that goes in there. What's being raised is the base. Okay, always. So whatever's being raised is the base. So in other words, then your 729 goes here. So I have log of 729 in the base 3 must equal to n minus 1. And of course, this you can do on the calculator and you get 6. So 6 is equal to n minus 1. Add 1 on to both sides and we get, of course, 7. So n is equal to 7. So now we have found that there are 7 terms in this geometric sequence.